A very good day to you. My name is Peter. I am one of the lecturers of the T4 module. This podcast introduces you to the subject of loops and conditions. Please find the R script podcast loops and conditions.r that accompanies this podcast. How do you work with this podcast? First of all, you should use the pause button if we are too fast. And secondly, you should reproduce the R code on your own machine while you are studying the podcast. You find this R code in the corresponding script file. The first thing you do now is you try out in R what the following code does. You find it in your example, just execute it now. Now that you have yourself executed this code, we do it here in R. So we go to our R, where we see exactly this code. I mark it and I execute it by pressing Ctrl R. And I see this. This should already have happened on your computer. So we see that here some stuff is printed. And in the end we have a value of 8 in the variable sum. Now let's understand a bit more systematically what happens here. For that we go back to the PowerPoint. You find the code on the left side. We initialize the value of sum with 0. Then we have the so-called for statement, and in brackets we write I in 1 to 4. Then we open a curly bracket, and inside this curly bracket we say sum equal to sum plus 2. The print statement that you have seen in the R code was just for illustration, so schematically this can also be left away. And we close the whole for statement with another curly bracket. Now what happens in steps? First step, you have the value sum equal to 0. Then R goes into this orange for statement and it sets the value of the variable I to 1. It checks whether 1 is less than or equal to 4 because 4 is the terminal number in this for statement. If this is the case, and this is the case, 1 is less than or equal to 4, R goes to the green block. So sum was 0 initially, and now sum is made to sum plus 2. Sum is 0, so this is 0 plus 2, so sum is now 2. After this has happened, I is automatically increased to I plus 1, so having been 1, it is now 1 plus 1 equal to 2. After that, R automatically goes to the condition, to the orange statement, with the value of I now equal to 2. Now on the right side we see what happens now. Again we are in the block, I is equal to 2, this is checked to be less than or equal to 4, this is the case, so we go to the green block. The value of sum is now 2, and in the block the sum is added to 2. So we have 2 plus 2 equals to 4. After this, automatically again I is increased from 2 to 3. And R goes back to the orange condition with now I equal to 3. Now 3 is still less than or equal to 4. So we do another loop. That's why it's called loop, for loop. It loops around here. So sum is now 4 from the last step. And again we say sum equal to sum plus 2, so gives 6. and again automatically I is increased to 4 and R goes to the orange condition with I equal to 4. Now I is equal to 4, this is still less than or equal to 4, so we can do the block once more. Sum has been 6 in the last run, so now again sum equal to sum plus 2, so we increase it to 8. And I again is automatically increased from 4 to 5, and R now goes to the condition, the orange one, with now I equal to 5. Now we see that the statement is violated. I is 5, which is clearly larger than 4, so we are not anymore in between 1 and 4, so the block is not executed anymore, and we finish the thing, so we go to the last curly bracket on the left side in red. And what do we have in the end? We have an output. First of all, the variable I is deleted. The variable I is only present in this green block statement. Afterwards it is deleted and is not there anymore. But the value of the variable sum, which was initially in the blue box 0, is now 8 after having done all these for loops. Now we would like to apply this concept, which sounds a bit abstract, to a very concrete example. Imagine that you are making some 200 experiments. Each of these experiments consists of 100 measurements. Let's assume that the measurements are numbers between 1 and 10. Maybe this is some kind of questionnaire or is some kind of experiment. I'm sure you can imagine something. Now you have those two experiments and you would like to put all the measurements that you obtained, so these 200 times 100, 20,000 measurements, into one big data frame to check with an ANOVA analysis of variance whether the 200 experiments provided comparable data. The focus is not here on this ANOVA method. You will learn that in T3. If you visit T3, maybe you already know something about it, and if not, it doesn't really matter. It's just a statistical test to see whether there is differences between those 200 experiments, and for that we need to have it all in one big data frame. And to realize that, we go to the R code. So this is now here the for loop experiment number 1. So first of all, for simplicity, we do not consider that we have data files to read in, but we produce our experimental data by ourselves. What we do here is not that relevant. It is a function that samples numbers between 1 and 10 100 times, and it replaces all the numbers. So I can take one number and it is again replaced. So you have to imagine that you take those numbers out of a box, and it could be that if you take the number out and the number is out of the box, but with replace equal to true, you put the number back into the box and take another measurement. Let's execute this function with Ctrl R. Let's maybe see what happens if we execute it once. Data underbar experiment. And since it's a function, I need round brackets, press Ctrl R, and that's what we get. This is a list of 100 values, each between 1 and 10. Alright, let's delete it again. I think it's clear. Now what we do is the following. We initialize two variables. One is called all data. That's supposed to be the container in the end that contains all the 20,000 measurements. It's at the moment empty. And we also initialize a container that is called labels, that shall contain the number of experiments to which the measurements belong. Now I see here the for loop. So I do the experiment 200 times. So I go for I in 1 to 200. And in each round of this loop, I make a new experiment. That means I get myself some random numbers between 1 and 10, so 100 of them. Then this new experimental data is put to the container all data, and this can be done easily in R by just concatenating it. So we say all data is the concatenation of the old all data that we already had. In the initial round this is empty, but afterwards it's filled. And we concatenate this with the experimental data. So this here should actually be new experiment. Right. So, because we have already assigned that up here. And then when we have done that, we also put labels. That means we concatenate the already present labels, and we put 100 times, it's the second number, 100 times the number of the current experiment. That means if we are in the first round, I is equal to 1, so this labels is still empty and is then filled with 100 repetitions of the number 1, since I is 1 in the first round. In the last round, where I is 200, we put 100 repetitions of the number 200. So this is the essential thing here, that's this for loop. And after that, we want to put the labels and the data into one big data frame, at which we can look at with the command structure or head, which you have certainly learned in the tutorial. And we can in the end do some ANOVA analysis to see whether the experiments are significantly different or not. So now let us execute all that. Let's say once till here. And now let's make this data frame, this line here. Control R, and now we can look at this data frame with the command str, and we see here that we have the 20,000 observations. We have two variables. One variable is a label of integers 1 to 200, and the other one is all data that should be numbers between 1 and 10. We can make head that it shows the first few numbers, or we can even display the whole data set with Ctrl R. And then we see here the labels in the middle column, right? They go from 1 till 200, and all the samples are in the right column. And since this vector is very long, R is not able to display all of it, so it's 20,000 values. If we want to do the ANOVA analysis, this is done here. If you know this already, it's fine. If you don't, you will learn it in T3 or you will learn it during practice. This is not the essential part of this module. So we just execute this. It takes a while since it's quite some samples. We have to wait a little bit. And then we see the result. So here we see that indeed the p-value is 37.6%. So there is no significant difference in between the 200 experiments. Now this was the first example, and now we want to extend this one a little bit. We want to extend it with another statement that is called the if statement. Let us just try what happens if we put this code into R. So let's mark it, copy it, then we have our R here. Paste it, and now we have it here. So we set a variable a equal to 5 and say that if a is less than 3, we want to print this statement, otherwise we do nothing. So if I have a equal to 2, and I repeat the if statement, then it should print a is less than 3, because now a is equal to 2. If statements are nothing complicated, they are like normal talking. So you say if a less than 3, then do what's inside the curly brackets. And this can be, however, very useful. Let's look at the example number 2. So now we have again our 200 experiments, each consisting of 100 measurements again, and numbers between 1 and 10 are those measurements. Now we have an additional condition. We say that we only want to take the measurements that contain less than 13 times the number 10 in one experiment into that big data frame and check with the ANOVA again whether these now less than or equal to 200 experiments provide a comparable data. So this is a very reasonable assumption. In practice you very often have such conditions. Just imagine that maybe you can have some measurement errors, so you say that if my number 10 appears more than 13 times that experiment, there was something wrong with the measurements, so I want to take this experiment out of my samples. Let's see how we do this in R. So, now we have the second example in the script file here. It's called for loop experiment 2. The first part is exactly the same. We have our experiment function and we initialize our containers all data and labels. So, now the fun starts. The first outer for loop is again the same. We go from 1 to 200, that's our experiments. We create our new experiment data in this line like before. And now we need to count how many times the number 10 is indeed inside that new experiment data. So we initialize a variable that is called sum10 to 0, because we don't know how many 10s there are, and initially there are just 0 of them. That's what happens in this line. Now we do a nested for loop. That means we do another for loop inside, because we need to go with another variable j. Be very careful, do not use the same like in the outer loop, right? Don't use the I, use a j. And this j goes now from 1 to 100, because we do 100 measurements per experiment. So we go through all the measurements in our experiment, and now we use an if clause. If the jth value of my new experiment is equal to 10, and be very careful that you put two equality signs, that is also mentioned in the preparatory material that you have studied carefully. Now make sure you have two equality signs. If this jth value of new experiment is equal to 10, then we add 1 to our variable sum10. So if we find no values of 10, then this variable sum10 will remain 0. If we find, for example, 5 values that are equal to 10, then this loop here would be executed 5 times, namely each time where we find this value 10, and the sum10 is increased by 1 in each of these 5 runs, so we get sum10 equal to 5. And then we close this inner for loop, and we have counted how many times we have the number 10, and the result is stored in this variable sum10. So if now we have less than 13 times 10, then we want to add the experiment to the data frame and otherwise not. So what we do is we check now with another if clause if this sum10 is indeed less than 13. If this is the case, we go to the curly bracket and put the random numbers into the all data container. This happens here, that is the same that already happened before. Actually, again here we should say new experiment like before, since this has already been assigned in the first line here. And we also put labels like we did that before. We say which experiment, that's the I, and we repeat that 100 times because our new experiment contains of 100 measurements. If it is at all, put them here. If the sum 10 is larger than 13 here, we do not put it and just continue, right? Then we start again up here. We create a new data, so I is increased by 1. We create our new experimental data. Sum 10 is again set to 0 because we need to count anew how many numbers of 10 we have in our now new experiment. Right? The one for the old run doesn't count anymore. So it's now about the new run, and we do all the same again. In the end, we assert whether we have less than 13, and if this is the case, then we just add the data to our old data and add some labels. We repeat this all 200 times and then finish this loop. Again, we make a data frame of all this, and we can have a look at this data frame with str, with head, or just with data. And we could also do an ANOVA, but we do not do that here anymore. So let's execute all that. First, let's just execute till the end of the for loop. And now let's make the data frame. And let's have a look at it. Control R here. And now what you see is you have not 20,000 measurements anymore, because obviously some of these experiments were indeed containing more than 13 times the number 10. So now you have 15,900 experiments. It can very well be that on your computer you have a different number here, since you are taking random numbers in this function. This means random, so it can be that in the next run we get a different number. Let's try that and see what happens. Let's run everything once more. Control R. And now you see that we have 15,500. So this is not a constant because we have random variables in our experiment. If we look at head here, we see that it starts with 1. And if we look at data here, then we might see which kind of experiments are omitted. So there is everything fine here. But here experiment 100 and where is it? Here the experiments 190, 191, 192, they are all omitted. Right? We don't see an index 190, 191 or 192, so we have omitted some of the experiments that contain more than 13 times the number 10. All right. Now, there are some questions. You should have understood this podcast as far as that you could now name at least 2 examples, maybe from your own research, where a for loop in combination with an if statement could be useful. You should be able to construct these for loops and if statements for the cases you have in mind on paper, so just write down the structure. And then finally you should be able to implement those in R. It is very advisable that you try to do this. We will make some 2 or 3 examples about for loops and also if statements in the course, but we will not come back to the theory. We are very much looking forward to meet you on Thursday and Friday this week.